I grew up not very far away from here in northwest Leicestershire, across the county line, and have fond, although very vague memories now, of travelling up with my friend Adrian from school in Leicestershire to Alfreton Computer Club, because we didn't have one down the road from us in Leicestershire. Adrian is now working for RIM in San Francisco, the people who make BlackBerry, and getting paid like 3 times what I'm getting paid. Is he happy? Well, yes, he is. So yeah, my day job is the University of Roehampton, training the next generation of outstanding teachers, which I have a whale of a time doing. Did 3 years as a primary school head teacher, hence prematurely grey hair, not nearly as old as I look. The plan for this morning is to tell you a little about some of, at least my thinking that went into drafting this new computing curriculum, and I think that of other people who are on the drafting panel, talk about some of the process that we went through in putting together a programme of study, then show you the programme of study as it now stands as a draft. We're waiting to see what the consultation responses produce, and then talk about some of the tools that you might use in order to move towards teaching that. It says new tools for a new curriculum, and we certainly do have a new curriculum. I'm not absolutely certain that new tools is a wholly appropriate title, in that many of the tools that we've been using for a long time now, for a while now, I think are still just as relevant, and then just give you a few sort of heads up towards some of the issues which we're likely to face. So this is where I work, or in fact this is where my Vice-Chancellor works. I have an office made out of breeze blocks some distance away from here. The University of Roehampton, like a couple of other universities, is a collegiate institution. It's made up of 4 colleges, at which I'm based at Froebel College. Now, Froebel College is named after the 19th century German educationist Friedrich Froebel, who invented the kindergarten. This is a 19th century German kindergarten. Who are the early years specialists in the room? Splendid, all sat over to this side. So do you reckon it would pass its EYFS inspection if they were to come looking now? Well, I'm not sure about the adult-child ratio. I think we're just inside acceptable limits, or what Liz Truss would see as acceptable limits, certainly. In terms of teacher-directed activity, there are grown-ups there, but they seem to be getting on with other things. The children, though, you have to admit, are engaged in learning, aren't they? What stimulating, what a rich learning environment. Look at all of that social interaction. Look at all of that interaction with their environment. And that's really Froebel's vision for how early years education had to proceed. He's famous for one other thing, or at least one other thing, which is the notion of the Froebel gifts. So again, early 19th century Germany coming up with this notion that the best thing to do in the early stages of a child's development is to provide them with these particularly well-chosen presents, these gifts, which this is, I think, 5 or 6 in a series of a dozen or so. So we have these building blocks here. Why do we put things like this into the hands of small children? Why do we give them... Okay, we have things like Lego and we have things like stickle bricks and similar sorts of things these days. But why do we do that? Why do we give children things like that to play with? This is not a rhetorical question. Anybody? Creativity, thank you very much. Absolutely. Any other answers? Open-ended? Exploration. Absolutely. Anything else?
Is that fine motor skills?
Of course, absolutely. Playing with that is going to help them develop these fine motor skills. Froebel's idea, and I think it was something which was taken up later by Piaget, was that through playing with things like this, children learn about how the world works. Conservation of number, conservation of mass, conservation of volume, all of these essential things in our understanding of reality at a very, very early age comes through playing with toys a bit similar to what you see on the slide behind me. We don't give them these toys so that they become construction workers or architects, although many do. Of course, many do. And, great American architect like Frank Lloyd Wright went to a Froebel kindergarten, and there are those who argue that Lloyd Wright's later architecture was influenced by those early childhood experiences. It's plausible, isn't it? Okay. So some of the children who play with these things will go off and get jobs in the industry, but it's more than that. And so something like Scratch, or BYOB Scratch, which you see on the screen behind me, which is produced by MIT's lifelong kindergarten group, no coincidence, that is about putting virtual building blocks into the hands of children. Not so that they become computer programmers and software developers and computer scientists, although I'm sure some will, but because playing with that sort of building block teaches children something of the fundamental nature of reality, of computation, of what is and is not something that can be computed. And I think that's why I, and at least some of the others on the drafting panel, was so pleased to see this recognition for a place for computer science and a place for tools like Scratch in primary education, because it's about understanding the world around us, as education jolly well ought to be. And of course, we have the Piagetian stuff of playing with things like this is how we come up with this knowledge of reality. And think about how you've learnt to use the technology that you use day in, day out. It is through play. It is through experiment. And I've got evidence from the Roehampton trainees that those who adopt that playful, you use the word explore, I think, and others might use the word experimental approach, seem to develop a better understanding of how technology works and of how the world works. And that's what my little daughter here, this was taken about a year ago, is doing with the laptop here. She is at that age developing an understanding, a mental model, a schema, if you will, of how the technology works. A little before that, her understanding of technology was, if I close the laptop lid, then mummy and daddy pay me attention, which is important. But by this point, she's discovering that some buttons make it turn on or make it go to sleep. And if she moves her finger across part of it, then things happen. If she moves her finger on the little square things, then other things happen. So this notion of input, process, output is already there in young Sophie's understanding of how at least a little bit of the technology works. And that's something which is going to develop and improve and be enhanced through her experience of education and through learning about computer science, learning to program computers. It's the bit in the middle, isn't it? The input, the process, the output. At the moment, for all Sophie knows, it could be little pixies inside the machine. But sooner or later, she's going to get an understanding that it's following instructions in order. Sooner or later, she's going to cross an abstraction boundary and think about how they're going to be stored in the memory or on the disk or whatever replaces any of those technology. And her understanding of how it works is something which will develop. I think this is a great quote. Can you read that from the back? I'm conscious that these are small screens in a big room. Just about. Anybody like me to read it out loud? Because I'm happy to do that. Okay, so we have there Seymour Papert, giving the game away now, put the next bit of the slide on, writing back in 1980 about this difference between computer-aided instruction, as he called it, technology-enhanced learning, as we might call it, ICT in education, as we might refer to it, and his vision for putting children in charge of the machine. Douglas Rushkoff describes it in terms of program or be programmed, and I think that's quite a nice distinction there. That too much of the time, we sit children in front of the telescreens and expect the computer to do some of the teaching. There's nothing wrong with drill and practice. I'm going to ask you some times table questions. If you get them right, I'm going to ask you some more times tables questions. But there's far more to ICT than that. And Papert's great vision is that we learn through building things for other people to see. And in this case, about writing software. And through that, developing an intimate contact with some of the deepest ideas from science, from maths, and the art of intellectual model building. Again, through building things on the computer, writing software, coming up with this understanding of how the world around us works. Demos, writing back in 2007, looked at young people's use of technology and saw that, broadly speaking, by the time a child leaves primary school, which year group are you guys in? Which year are you? Year 4 and you're? Year 4. So I reckon if I was to ask you guys to go and research something, you'd immediately go and do what? Go on the internet. Which web page would you go to straight away? I thought you were going to say, is it Google from you as well? Yeah. Okay, so we've got to the position that by year 4, a random sample of children helpfully provided. It's a good time you're here, guys. Their understanding of finding something out involves going onto the web and searching Google. And is there anybody in the room, just out of interest, who doesn't use Google as their search engine of choice? Kudos, respect. Okay. Anybody else? Do you not think that ever so slightly scary? That we've got to a point where one organisation controls so many people's access to information, ever since the Reformation. But anyhow, by the time they leave primary school, children automatically, very, very good, very skilled. Do you have problems finding things on Google? Do you normally get the results you want? Yeah, it's pretty good at that. It is pretty good at that. You know, they are very good as information gatherers. They're not bad as everyday communicators. I'm not going to ask you in front of your teachers which of you have Facebook accounts, because none of you ought to, of course. But they're good at staying in touch with one another by the time they leave primary school, thanks to the good work of primary school teachers. Less impressed were Demos about their skills, children's skills, young people's skills as creative producers. By and large, they weren't choosing to create stuff in a digital domain. Far less of them as digital pioneers, the ones who are teaching themselves new skills, new knowledge, new understanding inside that digital domain. So we have, those first two boxes, we're doing pretty well. Let's move forward to those next two boxes. Everybody in the room, I'm sure, will have heard of Assessment for Learning, AFL. Anybody familiar with TFL? Okay, it's an interesting concept. Takes the Assessment for Learning idea and just adds something. It's teaching for learning. Okay, it's an interesting idea. Okay, it's meeting people where they are, taking them on to some place where they wouldn't have got otherwise. I suppose a bit like Transport for London, who share the acronym there. So where are they? Again, it's easy to generalise and easy to make assumptions, but broadly speaking, by the time children leave primary school, they're good at using computers. They're good as users of technology. They're pretty good as consuming digital content, of going online, listening to music, watching YouTube videos, all of that sort of thing. Not bad at all as communicators, of being able to stay in touch with their friends, their relatives, being able to communicate with other people too. They are, broadly speaking, it depends what you mean, I know, digitally literate. They can read and write in a digital domain. They also, thanks to the good work of primary school teachers and others, good at keeping themselves safe online, thank goodness. And also fairly effective across a whole portfolio of skills. Who are the secondary school teachers in the room? Okay, scattering. Broadly speaking, satisfied with the skills of Year 7? It depends, okay, not so much. But many children leaving primary school with a fairly good portfolio of skills. Mileage may vary there. So where do we take them on to? We meet them there and then take them on to somewhere new. About moving from being users of technology, makers of technology, putting the tools into their hands to create new tools, content, whatever, in a digital domain. From being consumers of content to being creators of content. From seeing YouTube as the place where you go to post your video, not merely to watch video. From being effective communicators to being able to work well together with one another. From, yes, being digitally literate to being more critical in a digital domain. Not just being able to find the top results or the results you want on Google, but knowing how Google put that at the top of the list. How does Google produce that set of search results? And yes, from being safe online to actually being much more responsible online, not signing up for Facebook accounts before they reach the age when they're supposed to. From realizing that they have a moral responsibility in how they behave online, which extends beyond just keeping themselves safe. I hope very, very few of you have problems with children and the sort of stranger danger online thing in your school, but I suspect many more of you will have problems with children and cyberbullying online. If not in school, then outside of school for your pupils. And that move from safety to responsibility is, I think, an important one. And then, crucially, this is at the core of the new curriculum, moving from having a cluster of skills to developing an understanding of the technology. And that really is the key thing about this. For example, this is what Jim Rose came up with when commissioned by the previous government to come up to say what changes should be made to the ICT curriculum in primary schools. And he said we need to put ICT at the core of the curriculum alongside literacy and numeracy as something that is essential for learning and life. And came up with this really pretty good definition of what ICT capability encompasses. Children use and apply their knowledge, skills and understanding confidently and competently in their learning and everyday context, independent, discerning users of technology, recognizing opportunities and risks and using strategies to stay safe. It's a very good definition, I'd say, of what we understand by ICT capability. It is very much focused on using technology. Okay, knowledge and understanding is mentioned alongside the skills, but it is about using that technology and using that technology effectively, competently, confidently. This is what we get instead. This is the start of the preamble to the new programme of study. And this is miles away, I think, from where we were. A real change in the emphasis in the subject. And this isn't just computing. The rest of the curriculum changes too, from an emphasis on skills and being able to do stuff to that specification of core knowledge. So we're looking at being able to understand and change the world through computational thinking. I look forward to hearing how you get on with that, by the way. You know, how many of your children are able to change the world through the power of computational thinking alone. We'll see how that goes. Notice the word creativity in there. It's amazing to think now that Jim Rose either didn't think it needed to be said or chose not to say about creativity. But also rigor, obviously, the Secretary of State's going to go for that. Creating purposeful and usable artifacts, making things for other people. It's this Papert vision of we learn best through making things for other people. And understanding, again, natural and artificial systems. That emphasis, the word understanding comes up 3 times here, pretty much in the same context in each case. This is how we teach, isn't it? We say the same thing 3 times and hope they get it at the end. I asked my new trainees to evaluate themselves in a cluster of 18 skills. But I now also ask themselves to grade themselves in terms of their knowledge and their understanding of technology. And this is the graph we get when we aggregate those results. So their skills, by and large, by the time they get to Roehampton, pretty good. What's that? 2/3 of them grade themselves as competent, proficient, or expert in terms of their skills using ICT. In terms of their understanding, I've got 15% of my trainees who say that their understanding of technology is competent, proficient, or expert. Very few in that last category. And that bothers me. That's the real challenge for me in my role at the moment, meeting them where they are with this great set of ICT skills and moving them on to a place where they've got an understanding of technology. And I think that's going to be your challenge too when it comes to the new computing program study. Teaching them to program is not that difficult. Look, if you can teach them to use PowerPoint, if you can teach them to use email, you can certainly teach them how to program in Scratch. Developing that understanding of computation, that understanding of technology, is a different thing entirely. And that, I think, is going to require or draw on your knowledge of technology, your understanding of how these systems work and interrelate. Okay. So the secondary school teachers, any of you teaching ICT at A level? Okay, so you'll be familiar with the diagram on the slide behind me, or something very similar to it, yes? This is what we teach in terms of how software gets written on most A-level ICT specifications. It's called the Waterfall Development methodology, and broadly speaking, it's how you commission and develop big software projects. Somebody wearing a really nice suit comes up with a list of requirements of what the software has to do. It's got to sort of manage the NHS or whatever. Other people wearing not quite such nice suits, but still wearing suits, meet together and design the specification. They take those requirements and put those into a more technical framework of this is exactly how it's supposed to work. Other people, generally not wearing suits by this point, generally not getting paid so much, generally not having much say in what happens, have the job of implementing that. They call them programmers. It's really important as part of this methodology that the software is tested, that it does what it was supposed to do, and then there's usually an ongoing contract for the maintenance. We send out a service pack every now and then and make sure it's working. Broadly speaking, the right idea, A-level ICT teachers? Yeah, that's close enough, I hope. We kind of do the same thing, don't we, when it comes to putting a curriculum together. Somebody wearing a nice suit and generally sort of dark spectacles these days and looking a little goggle-eyed, you know what I'm talking about, comes up with a set of requirements. You know, history should be taught in order, or you know, computer science should be on the curriculum. Other people, generally not wearing quite such nice suits, meet together in conference rooms at the Royal Academy of Engineering or wherever and come up with a design to make that happen, the programme of study as you see it. Other people, generally not paid so much, generally not getting much say in exactly what happens, have the job of implementing that. In our line of work, we call them teachers. Sorry. And then we do plenty of verification, don't we? Testing is kind of important in our line of work too. That, you know, we need to make sure that what we've done actually does, you know, meet the requirements that we set out to achieve. And then occasionally, when it's obviously not working properly, we get QCA as was to produce the schemes of work. And, you know, here's a service pack, you know, have a go at it this way. So just as that works incredibly well for large public sector software procurement, like the NHS database. Okay, I think the analogy breaks down there. I'm sure it does. So, you know, it was my great pleasure to be part of the design team at this stage, and of course I'm going to be responsible for some of the implementation and training new teachers. This is what they came up with last time. So until September of this year, this was what we were expected to teach. This was the statutory requirements from 1999. Do you remember what computers were like back in 1999? Windows 98, anybody? Yeah? If you were really unfortunate, Windows ME, did you notice how Windows operating systems go good, bad, and sort of all the way through? Windows 7 was absolutely fine. I'm saying nothing more. You had connecting to the internet involved going, yeah? CD-ROMs, software on CD-ROMs, and all of that. So very, very different back then. Nevertheless, it stood the test of time incredibly well. The people who wrote this did a really good job. Which of these things do we not want to carry on teaching? Finding things out, developing ideas, making things happen, exchanging, sharing information, reviewing, modifying, evaluating work as it progresses. These things still matter. Yeah? Their great insight was not specifying technologies, apart from email, which is the one thing we should say you have to teach. Everything else is about ideas and the uses of the technology. And, reviewing, modifying, evaluating work as it progresses. Why limit that to ICT? Are you not going to be doing that like across the whole of the curriculum? So that was what we had. There were criticisms made, partly down to the interpretation of that, partly due to the way it was assessed at GCSE, I'd think, partly due to the focus on things which do really matter about working with information and not so much on developing an understanding of the technology itself. It's very much a skills-focused curriculum, to be fair. And so folks like Ian Livingstone and Alex Hope commissioned by DCMS, Department of Culture, Media and Sport, to report on what could be done, what should be done about their industries to get them back to sort of world ranking there, said the first thing to do is to address the pipeline, to make sure we've got enough good programmers, computer scientists coming in to the industry. And that means making sure that computer science is taught as part of the national curriculum. So Ed Vasey reacted very positively to that. Michael Gove, a good friend of his. Then you get this man. Anybody know who Eric Schmidt is? Okay. Google's executive chairman. So of those people controlling our access to information, he's one. So talking at the Edinburgh International Television Festival, hopefully this works.
I was flabbergasted to learn that today computer science is not even taught as standard in UK schools. Now, your IT curriculum, by the way, focuses on teaching how to use software, but it doesn't teach people how it's made. This risks throwing away your great computing heritage.
I think possibly a little unfair in that we did have writing instructions, creating sequences of instructions there on the old national curriculum. So not entirely accurate. You'd have thought you could have checked that by, I don't know, like Googling it or something. But nevertheless, we'd have to admit our focus wasn't on that part of the curriculum. So possibly throwing away our great computing heritage. The Royal Society, commissioned by a number of university computer science departments, British Computer Society and others, to review the whole position of computing in education, said that one of the problems was the ICT brand. And I don't think it was the fault of most of us who were teaching it. I think it was to do with using ICT as the title for relatively limited GCSE specifications, which focus much more on the office skills side of things than on the understanding or on that broader stuff, which we did have in the programme study. So one of their recommendations is we need to rebrand it. We need to move away from ICT, which they saw as damaged goods, to calling it computing. And they saw it in terms of these three components of it. Digital literacy, something, what every child should be expected to take with them into secondary school. I think their definition was far too narrow. Of information technology, a discipline in its own right, and of computer science. And I think that was a very influential report. The day before this was published, the Secretary of State, bless him, stands up at BET, January 2012. I ought to say, replace ICT with these three things. You can imagine how a diagram went down at NACE. The Secretary of State stands up at BET and says, actually, the problem has been the programme of study, not what I just suggested it was, and says we should disapply that.
Imagine there's going to be a dramatic change in just a few years' time. Once we remove the roadblock of the existing ICT curriculum, instead of children, bored out of their minds, being taught how to use Word and Excel by teachers, or even more bored, we could have 11-year-olds able to write simple 2D computer animations using an MIT tool called Scratch. By 16, they could have an understanding of formal logic previously covered only in university courses. They could be writing their own apps for their smartphones. This isn't an airy promise from an MP. This is the prediction of experts like Ian Livingstone, who've already built world-class companies from computer science. Now, these new computer science courses will reflect what you all know. The subject is rigorous, fascinating, and intellectually challenging. After all, the founder of Facebook, Mark Zuckerberg...
Have a drink. Okay, so he says that the reason why we've not been teaching computer science, not doing the programming, is because of the constraints imposed by the previous program of study. I think unfairly so, because we could teach whatever we wanted, as long as we also covered the program of study, and there was programming there on the program of study anyhow. So his solution is to disapply the program of study. For these 2 years, this year and the next academic year, you can teach whatever you want in ICT. And I know that there are schools who've taken that opportunity and gone, developed really interesting, stimulating computer science programming courses, but there are plenty of schools who've just carried on doing what they were. And I know that there are some schools, particularly in the secondary phase, which just said, oh, well, if we don't have to do anything in particular, then let's just cover it somewhere embedded in the curriculum and not treat it as a proper subject in its own right. So if you want to do that, Mr. Gove, if you want more computing, then letting schools choose what they do, disapplying the program of study, is probably not the best way to do it. So that's what we wrote in our response to the consultation about disapplication. And he thinks again, credit where it's due, he did kind of change his mind on that. That actually, because we recognise it's such an important subject, we will put ICT on the national curriculum with a statutory program of study for all 4 key stages, not what we were expecting from September 2014. Alongside all of the other national curriculum subjects, rejects the expert panel's recommendations, rejects at least some of the Royal Society's recommendations, and says, yeah, let's do it the same way as we used to, but have a new programme of study for it. Unlike all of the other national curriculum subjects, he's going to produce the programme of study rather differently. As with so much in IT, he's going to outsource this, and outsources it to the British Computer Society and, interestingly, the Royal Academy of Engineering, as honest brokers to bring together stakeholders across the sector, form a small working party, produce a draft, get some consultation done on that draft, and then hand it in as expert advice at the end of November. I think we handed it in at about 4:45 on the 30th of November, so it's not just your pupils who leave things to the last minute. No, we started earlier, to be fair. Okay, process there, the invitations sent out in August. We were each asked to produce our own sort of straw men as to what we thought should be on there. September, the DFE signed a memorandum of understanding, and we started a process of iterative development, of let's take this as a draft, see what we can improve on that, and went round and round that circle a number of times. Simon Peyton-Jones from Microsoft Research, who chaired the discussion, said, never have so many people spent so much time on so few words. We're limited to just 2 sides of A4. We even had a meeting where we talked about where the commas should go. I was there. Okay. In October, more development, roundtable chaired by, or the last half hour was chaired by David Willits from BIS, and an open consultation process. We released the draft and saw what the community thought and made changes on the basis of that. A second drafting group in November with more industry representation handed that into the DFE on the 30th of November. They looked at it and said, go back and do it again properly, and asked just a few people from BCS and RANG themselves to produce some changes for that. If you want to see more about the process or see the draft that we submitted, bcs.org/ICTPOS will give you more detail of the process there. So yeah, ministers reviewed the draft, said that we needed to shorten the aims, increase the emphasis more on computer science. It was already there as a significant component. Strong links to the maths curriculum, I'm not sure what's happened there. Edit and condense the digital skills, so moving the focus even further in the direction of computer science and programming. And then they produced the final version for public consultation on the 7th of February. He stands up in the House and says we're going to replace the ICT curriculum with a new computing curriculum, so that is going back to the Royal Society recommendation, with help from Google, Facebook, some of Britain's most brilliant computer scientists, and Miles, but I didn't say Miles. Okay. I do remember one meeting where somebody from Facebook was there, but I don't remember them saying anything. Perhaps they just liked it, I don't know. Okay. If I wasn't running so short of time, I'd ask you to talk with the folk around your table and do this in a much less sort of presentation type manner, and ask you to come up with your answer to this question about what is the curriculum for? What are you trying to do? What are your aims? What is it you're trying to achieve? It would be nice to do that, but I'm going to run out of time if we do. Let me tell you the answer on the card, though. This is your statutory obligation. Any maintained school, I think this applies to academies and free schools as well as local authority maintained schools, has a statutory obligation to do two things: promote the spiritual, moral, cultural, mental and physical development of pupils at the school and of society. Later on today, I'd very much like answers about what your school is doing to promote the physical development of society, but we'll see how that goes. And prepare pupils for the opportunities, responsibilities and experiences of later life. The statutory requirement stuff, okay, it's in the 2002 Act. And that's not bad, is it? Ensuring their development as young people, preparing them for the opportunities of later life. Yeah? If we had broken into small groups and discussed this, I bet these are the sorts of things that you'd have come up with yourselves, or at least I'm hoping that they are. Yeah? If you've got something else in mind, then you need to go and check what the law says you're supposed to be doing. But this is a very, very good place to start. It really is. And the Secretary of State has to ensure that he does this too. In producing a national curriculum, he has to pay attention to these statutory requirements. He is not, despite what you may think, above the law. This is what he says, though, the new national curriculum aims to do. The new national curriculum aims to provide pupils with an introduction to the core knowledge that they need to be educated citizens. It introduces them to the best that has been thought and said, helps engender an appreciation of human creativity and achievement. This notion on core knowledge, this notion on what E.D. Hirsch, one of the great thinkers behind this approach, describes as cultural literacy, the best that has been thought and said. It's focused very much on passing on the best that the previous generation's cultures, your 200-year now, know to the new generation. And that may well be the best way to do this. Yeah? The best way to prepare for the future is to have a thorough grounding in what we as a species, as a society, as a culture, as a community have thought and said and learnt in the past. For a large chunk of human history, it was. The best way to prepare for life on the African savannah or wherever was to know how your ancestors coped with life on the African savannah. There are those, though, who argue that things have changed now because of the rapid pace of technological and all other change. The best way to prepare for the future may no longer be merely to know the best that was thought and said in the past. But thankfully, you're not restricted to just doing that. Notice bullet point 3.2 there. There is time and space in the school day and in each week, term and year to range beyond the national curriculum specifications. Well, it says so in the curriculum document, so it must be true, mustn't it? Okay. But hold on to that. Please hold on to that. If you don't like what the new national curriculum says you should do, then remember that you can do anything else as well. Yeah? It's illegal for the Secretary of State to tell you how long to spend on any of this. You have to teach it, as long as you're in a local authority maintained school. Terms and conditions apply. But you can teach other things too. And that is crucial. And, he's saying you should be teaching other things too. The national curriculum provides an outline of core knowledge around which teachers can develop exciting and stimulating lessons. I like the use of the word can in there. Does that remind you of any sort of learning objectives or assessment outcomes? So the computing curriculum, it takes those three ideas from the Royal Society and has those three components. And of course there is more emphasis on the computer science bit, but there's also applying IT. Information technology remains part of the curriculum, and also this expectation that pupils will be digitally literate, expressing themselves through information and communication technology. We have 4 aims, two of which are around the computer science thing. Notice this distinction between the computer science stuff, the fundamental principles of how computers work, and thus how the world works, I suppose, and the craft skill of writing code. You've got to have both in there. It's not just enough to do the programming. How will you acquire that knowledge of computer science? Through the practical experience of writing code, certainly in the primary phase, I would expect. Also being able to evaluate and apply IT, also being responsible, competent, confident, and creative users of ICT, so the digital literacy stuff. We did have a 5th aim, which that he said, no, you've got to get rid of that, which was about a critical understanding of the implications of this technology for us as individuals and for society as a whole. But a critical understanding of implications is clearly something which we don't need to specify. Is it? Hold on to the word creative there, because it's an interesting one when it comes to the implementation of this. So what do we get? This is the Key Stage 1 list. Understand what algorithms are. Could you put your hand up, please, if you understand what an algorithm is? That's good. Could you four please explain to the rest of the group now? Okay. The use of technical vocabulary in primary education is something which we no longer really have problems with. When I was at school, what was called a magic E is now called a split vowel digraph by children in reception. Yeah? So they're using technical vocabulary. The fact that algorithm is something which only 5 of us were willing to put our hand up and admit that we knew. It's just a word that you need to learn. What we're talking about is a set of instructions to achieve a particular outcome, to get something done. Yeah? My favourite analogies for this, and you might have guessed that by just looking at me, are the cooking ones. The recipes are essentially algorithms. It's a set of instructions to get something done. Yeah? And this is how software developers work. They think of the way to get it done and then code it up as code, or at least it's what they say they're trying to do. Again, those are implemented as programs on digital devices. So you see the computer science and the programming bit. We have the algorithm, how to get it done, and then we have the programming bit, which is coding it up on the device. Writing and testing programs, using logical reasoning to predict the behavior of simple programs. Well, that's kind of what you do most of the time. If I press this, I expect it to do that. The really interesting occasions, the Piagetian cognitive conflict, is when it doesn't do what you expect it to do, of course. Organising, storing, manipulating, retrieving data in a range of digital formats covers everything that you could almost everything that you could possibly think, yeah? So anything you've been doing in ICT thus far in Key Stage 1, almost certainly covered by organising, storing, manipulating, retrieving data in a range of digital formats. If you feel constrained by the national curriculum, then anything which you want to teach is almost certainly covered by that bullet point. Painting a picture on a computer, I'm organising, storing, manipulating, and retrieving data. Making video, making animation, recording sound, doing podcasts, all covered by that bullet point, if nowhere else. Communicating safely and respectfully online, and of course this wasn't mentioned back on the 99 programme of study. Keeping personal information private, recognising common uses of ICT beyond school, which was something which obviously early years paid attention to. So e-safety is there, and notice there's also an element of responsibility as well as safety coming in there, and keeping your information private is the key message. There are a number of us who think it ought to also said how to report issues that you have. Very quickly, a few examples of this. So this is your algorithm stuff. This is somebody who was, I think, interviewed for a job at Microsoft, came up with the perfect specification of how to make a jam sandwich. Americans call it a peanut butter and jelly sandwich. So we have a 14-step algorithm there. Sorry, 15-step. It starts at step 0. Very cool, that. As an example of an algorithm for getting something done. And you can come up with lots of other examples and similar situations yourself. You'll do this all of the time in school. Getting ready for break, we have a set of steps that we follow. It's very, very easy to contextualize this algorithmic thinking into how we do things in primary school. And of course, writing and testing simple programs, it doesn't say on a computer. And even if it did say on a computer, there are 3 computers illustrated on the screens behind me. They have input, they store programs, they produce output. They are computers. Yeah? But all of the stuff which you could do with a Bbot, or if you've used it, a Probot or a Roma, is about writing and testing simple programs. It doesn't have to be writing code in Python or Haskell on a black screen with green letters on it. You can do that in Key Stage 1, I'm sure you could, but it might be more appropriate to start with concrete, manipulative, physical devices. And if it were me, I would expect by the end of Key Stage 1 to moving on to some screen-based programming, and there are lovely tools for that on the iPad and indeed on computers in general. And then we have using logical reasoning to predict the behaviour of simple programs. Isn't that what you're doing when you're playing Angry Birds? Yeah? Is that, what else is that but apart from using logical reasoning to predict the behaviour of simple programs? I don't think it's what most of those who sat round the table with me had in mind for this statement. But there is no canonical interpretation. There isn't going to be the set of, I don't think there's going to be the set of notes about what these words have to be interpreted to mean. And I think there's a great opportunity here for lots of interest in game-based learning. of thinking about what's the program underpinning this game? How has this game been produced? What are the rules? What's the algorithm that is embedded within the program that makes the game? And of course, something like Angry Birds, so many learning opportunities there. The whole gravity thing is very, very clearly illustrated. Managing limited resources, that's something which many of us have to cope with, isn't it? Angry Birds is exactly like something like that. Cause and effect, yeah? Trying ideas out, making predictions. So game-based learning, there's plenty of opportunity. Organising, storing, manipulating, retrieving data in a range of digital formats, whatever you want. Too simple is just there as an illustrations. To paint a picture, yeah? To do it yourself. To connect the concept mapping thing, to calculate their spreadsheet tools. All of these are examples of programs in which you will organise, store, manipulate and retrieve data in a range of digital formats. I'd say go beyond just using the software to look at the file sizes it produces, look at the file formats that it produces, to do it yourself. Lovely example of that, in that you can produce its own native file or it can compile it down into a Shockwave Flash file and compare and contrast that. So you're thinking about the data as well as the information there. But, all of those things cover that particular box. Communicate safely and respectfully online, keeping personal information private. You know lots about that already, I'm sure. Recognising common uses of ICT beyond information technology beyond school. I'm involved with, or I've helped write the Rising Stars Switched on ICT scheme. And for all of those units, what we've done is try to find a real-world context for some of these. So, Key Stage 2, they're going to produce a newsletter, and we call that We Are Journalists. So we're looking at the sort of uses, Year 2, the sort of uses which journalists would put computers to, getting children to do similar things themselves in the classroom. Okay, we are astronauts programming on screen, not quite what most astronauts do, I suppose, but we are zoologists going and collecting data on our mini-bee safari on our bug hunt. Exactly what many zoologists would use computers for. So recognising some of the uses of ICT beyond school, and of course, what better example of the common uses of IT beyond school than the sort of phone and tablet type deployments that you're seeing. And I know that there are going to be a number of folk in the room who are using iPads and possibly using things like iPod Touches or even phones in interesting and effective ways. And that's one example of common uses of IT beyond school, I'd have thought. I will pause for a moment if anybody wants to add or argue with any of that. Key Stage 1. Okay. Then moving on to Key Stage 2, we've got 4 whole bullet points here which are focused on the computer science side of things, so more programming, designing and writing programs with a particular goal in mind. There is emphasis on the control side of things, but we deliberately didn't require controlling physical systems because of the resource implications, so simulating physical systems. Writing a game is simulating a physical system. Solving problems by decomposing them into smaller parts. So you've got the computational thinking thing there. Algorithms in Key Stage 1, one thing after another. In Key Stage 2, decomposing problems into smaller parts and solving each of those parts. Then specific details about programming, sequence selection and repetition in programs, working with variables and various forms of input and output, generating appropriate inputs and predicted outputs to test programs. Using the logical reasoning thing again, and correcting the programs, detecting and correcting errors in algorithms and programs. Why doesn't it do what it should do? This is how so much of the learning in programming, and indeed in computer science, will take place, I'm sure. And then this is quite ambitious for Key Stage 2, I think. Understand computer networks, including the internet. By the end of Key Stage 2, well, understand at least some of it. Provide multiple services such as the World Wide Web. Notice the distinction there. The internet and the web are different things, and that's something we want children to be aware of by the time they leave Key Stage 2. The opportunities they offer for communication and collaboration, really important point going in there. It's not just a theoretical understanding that we're looking for. More at Key Stage 2. This is my favourite on the whole list. Describe how internet search engines find and store data. This was added on after the 30th of November. I had no part in this. I can tell you how an internet search engine finds data. How an internet search engine stores data is a far more challenging thing for me to explain to anybody. Because you either do it in an incredibly trivial way, like on a disk, in a table, or you've got to get into the detail of the Google filing system and Bigtable, and really technical concepts which don't usually find themselves on undergraduate degree courses in computer science before kind of the third year, really. And I don't think anybody intended that that was what we would be teaching primary school children. It's just some words. Let's put some words in here. These are words. They'll have to go. Use search engines effectively, of course, discerning and evaluating digital content, respecting individuals and respecting intellectual property, really important responsibility points. And again, use technology responsibly, securely and safely. So the opportunity to talk about information security, the need for backup, the opportunity to talk about encrypted connections to the web, and so on. And then we get the big coverall statement at the end. Select, use, combine a variety of software, including internet services on a range of devices to accomplish given goals, okay? Including collecting, analysing, evaluating, presenting data and information. My friend Ian Addison, who teaches, I think it's year 4 in Hampshire, showed this to his children and said, one of them said to him, Mr. Addison, do you mean like using stuff on stuff to do stuff? And Ian said, yeah, I think that's kind of what it means. So if what you want to teach is covered somewhere along using stuff on stuff to do stuff, that's the bullet point which you need to put on your lesson plan, okay? Anything you wanted to teach, you're allowed to teach. And remember, you can teach more than this too. So a few examples of this. I'm conscious of time passing. We won't just have time for all of these. So writing programs include controlling physical systems.
Unless they have been turned off before by the tail by being squeezed.
Very good.
So we need to...
will like students come on and stay on? Or are they going to flash?
They're just going to come on and stay on, static, and then both about the
Have you got
same.
a word
I
you
think
need?
it should be off and short of it.
Yeah.
It's about 250.
And then we need to change that to half a second. But we need to sort this out so it's not with the thing. Times,
You get the idea. Saturday morning workshop in children's home about using Arduino to take control of these soft toys that they've hacked. They've cut through and put motors and flashing lights in. You can imagine tears before bedtime. And of course, the Scratch stuff. If you can write a computer program in Scratch that either does a very simple game or does the usual drill and practice maths test, I'm going to ask you some times table questions. If you get them right, I'm going to say well done and can keep track of your score. Then you are using sequence, putting steps in order. Selection, ifs, thens. Repeats, because you're going to go around the loop sometimes. Working with variables, yes, because you're keeping track of the score. Various forms of input and output. Okay, well, one form of input you're typing on the keyboard, one form of output it's displayed on the screen, but we can extend that easily enough. And then testing it by just seeing whether you get the question right or wrong. That's that bullet point covered. I could probably do that within an hour's workshop if push came to shove. You might want to spend more than an hour on that statement during the whole of Key Stage 2. But you can cover it very, very simply using Scratch. Drill and practice maths game, or slightly more interesting, chase the thing around the screen game in Scratch will cover that bullet point if you are worried about covering that. But you want to build up to that, I'd have thought, during Key Stage 2. And the debugging thing, I'm not going to show you the clip here because we really don't have time. But you will encounter, the children you teach will encounter so many problems that they'll need to fix when they're playing with Scratch. And that's where so many of the opportunities for the learning happens.
Using a variable to store.
Thank you. The difference between the internet and the web, very, very simply. The internet's like all of the connections, the machine, the access points, the routers, the gateways. The web is the information stored on some of those computers. Yeah, some of the computers connected to the internet are web servers. When you send them a request saying, show me this page, they respond with some of that HTTP. There are other computers connected to the internet that do other things, like looking after email or looking after BitTorrent. Nobody in the room will know what BitTorrent is, I'm sure, or looking after Skype. So all of those are services which the internet provides. Two different things. The internet, 1969, the web, about 1990, Tim Berners-Lee, British invention, which we gave the world for free. More of that. Oh, shush. Thank you. Opportunities they offer for communication and collaboration. Anybody doing Julia Skinner's 100-word challenge? Brilliant, brilliant opportunity to use a blog for a purpose. So she sets out, she's a former head teacher, she sets a 100-word creative writing challenge every week, I think it is, and children across the country and now world writing with 100-word responses. It's only 100 words, which works both ways. For reluctant writers, it's only 100 words. For those who would like to write page after page, it's only 100 words. And then David Mitchell doing this quad blogging thing, connecting 4 schools together. They each read and comment on one another's blog posts. And then how internet search engines find and store data. This is a photograph of one of Google's data centers. I bet you didn't know they use stormtroopers to keep your data secure. But, you know, using technology responsibly, securely, and safely, you've got to have a stormtrooper there to look after it. And a little R2-D2 in the foreground. Okay. And then this, using stuff on stuff to do stuff. So many opportunities for this. The Google Apps suite is great for this. And of course, there's Office 365 from their principal competitor. I'm running out of time. Typical. So Key Stage 3, loads and loads of computer science. You thought Key Stage 2 was bad. Wait for it. Key Stage 2, you've got 2 programming languages, one of which has to be textual. I think the smart money is going on Python or possibly JavaScript for that. Boolean Logic coming in there, ands, or, and nots. Some of that seems a little bit quaint to my mind, but there you go. Oh yeah, and at least 2 key algorithms for sorting and searching. Understanding the hardware and software components that make up computer systems, how instructions are stored and executed, von Neumann architecture, fetch-execute cycles, and manipulating binary. I don't think carry out some such manipulations by hand means creating your MP3s by shading in squares on paper, but it could be interpreted like that. Oh, and then a couple of bits just at the end. Now, this is the first use of the word creative or creativity in that program study. So it's there as part of the aims. Key Stage 1 and 2, nothing about creativity, and I think that was a great omission. We didn't leave it like that when we handed it in. And, you know, there is also a digital literacy one, but the only reference, as far as I can see, to e-safety in here is attention to intellectual property, and it seems strange to try and cover all of the e-safety stuff at Key Stages 1 and 2, when that's like 3 years before they get their Facebook accounts, and you might want to mention that sometime during Key Stage 3. Here's Key Stage 4 for you. That seems relatively straightforward, doesn't it? Keep calm and carry on coding. I think we kind of wimped out when it came to Key Stage 4. So yeah, the public consultation closed yesterday. If you don't like what you've seen, you should have said by then. Please remember, you'd have to do this, but you can do other things too. It should be ready for September this year, so you know you've got a year's lead in before it becomes statutory in September 2014. Do remember this only has legal effect in local authority maintained schools. Those that have turned to academies, free schools and independent schools are exempt from all of these requirements. And that seems strange. We've moved away from the notion of national curriculum as minimum entitlement for all children here. That if your school opts out of local authority, its relationship with the local authority, it also opts out of having to teach all of this. It is a minimum, not a maximum, and thus much of it becomes effectively optional. I'm out of time. Okay, there is that issue about a post-national curriculum phase. You know, it's possible if once every school becomes an academy, which I'm sure the Secretary of State would be happy with, ourselves perhaps less so, then this may be the last one ever. So what point is there if every school no school has to follow it? Assessment hasn't been dealt with. I'll show you the bullet point on assessment in a moment. Teacher training is an issue we're addressing. CPD is going to be a huge issue, and I hope Derbyshire is going to be addressing that. Where are the schemes of work? We have no QCA. Okay, I'm getting nods and shakes. Right? Where is the QCA scheme of work? Well, thankfully there isn't one. You can write a scheme of work yourself. It isn't rocket science. Well, it's computer science, but it's not rocket science. Writing a scheme of work for this is not beyond you. It really isn't. Gather together with the schools in your area, work together as a county, produce the Derbyshire scheme of work for this. Why not? Where do we find the resources? Well, we're sort of knitting some of those together. And the big question for me is the pedagogy one. Believe me, I can teach Scratch as badly as I ever taught PowerPoint. Yeah? If you stay on for the next workshop, you'll see that for real. Okay. You know, it's not about what we teach, it's how we teach it. Secretary of State is saying children are dull and bored because of these lessons. Moving from PowerPoint to Scratch isn't going to solve that problem. It's teaching it in a way which recognises things like play and creativity and exploration and experiment. You know, if we see computer science as a science, the best way to learn this is through experiment and investigation and exploration. So yeah, he says that we're going to move away from the current system of levels and level descriptors and not replace them by the end, and this is the attainment target. He has to provide an attainment target, statutory obligation on him. So this is the attainment target for every subject on the new curriculum. By the end of each key stage, pupils are expected to know, apply and understand the matter, skills and processes specified in the relevant program study. That's it. No levels. Okay? Have they learnt what you should have taught them? is what it comes down to. I see this as tremendously liberating. Is it not more useful as a Year 5 teacher to have a list of what Year 4, each of the children joining you from Year 4 have learnt, than this child is level 4B or this child is level 3A? Yeah? That granular approach to assessment may well be the best way forward, I think. Others disagree with me on that. Okay, and we're waiting for advice. The how to do assessment of the new programme of study, the new curriculum, hasn't yet emerged from the DFE. We'll see. Badges are interesting. Who's involved with Cub Scouts, Brownies, guides, that sort of thing? Okay, you know how badges work, yeah? It's a granular approach to assessment. Here's a list of criteria. When you meet the criteria, here's your badge to show that you can done that, yeah? You can do that at a very granular level, or you can do it at a really big level, like Queen's Guide or Queen's Scout or whatever, which encompasses a whole host of skills, knowledge and understanding that sums that up. And there's interesting work being done at Mozilla, your partners in search, people who brought you Firefox, about an infrastructure to underpin badging individual skills and badging competencies and literacies. On the initial teacher training side, this may be useful for those in the profession already and those addressing continuing professional development. So Teaching Agency commissioned a small group of us to produce, curate a collection of resources, not to write stuff from scratch, but just go and find the good stuff that's out there to support learning about the new curriculum. And we've put that together on a website now at bit.ly ITTComp, which may be of interest. One of the models which we think in terms of is this TPAC model about technical knowledge, pedagogical knowledge, and content knowledge. And at the heart of that, if you can tick all three boxes at once, there's a good chance that whatever teacher training, whatever CPD you're doing is something which is likely to be quite effective. And I think making things is going to be the way there. So Pappert's notion, again, of consciously engaged in constructing those public entities lies at the heart of that. So the best way to equip yourselves with the knowledge, skills, understanding for this new curriculum is to get around a table and make stuff for the new curriculum, make interactive resources using something like Scratch. Get around a table and write a scheme of work or create some lesson resources that you can use. And through that, I think you'll get a far better idea of what's involved than going on a course and learning how to program in Python in a very abstract manner, I'd suggest. So thinking about scheme of work, I see that there's being those sort of 6 areas there. There is the coding, the programming stuff. There's the other bits of the computer science, the computational thinking almost, how the networks, how the internet works, the opportunities for communication and collaboration. Please do build in creativity. Okay, it's not mentioned explicitly on the list, but doing stuff on stuff to achieve stuff, or whatever the phrase was, covers it surely. And also getting things done. Just because Office isn't going to be the focus doesn't mean it's not a jolly useful set of skills to have. And then embedded across those, the computational thinking, which applies not just in writing software, but in getting lots of things done. Project management is a computational thinking discipline, really. An emphasis on design, about the end user's expectations and needs, being more critical about stuff, and taking responsibility, which is not just in terms of online behaviour, of course. And it is about knowledge and understanding, not just skills. I'm sorry I've overrun. Do we have time for questions now? We've got to go into workshops. I'm sorry. Yeah. Okay, I'm going to hang around and talk a little about Scratch for some people, but there's an email address up on the screen. There's a website, which is a blog that I very rarely maintain these days, and I'm also on Twitter. So I'd be very, very happy to respond to any questions, whatever, afterwards, if not necessarily now, I'm afraid. So thank you all very much.